No, mic is not Yeti. Okay. Hello, hello. Okay, now you guys can hear me. Alrighty, dighty do. Hopefully, everyone can hear me. The captions are on, so should be good. These captions are like not generated by me or a software by me. I just use Google's a plugin that uses Google's Translate API. So if some things are not clear, let me know. And if there are any issues. Hopefully, you guys are doing well, right? So sorry, last week I was super sick because of the burnout. I was like legit not doing well, right? Like, so because of those things, could not do a stream, even a single one. Like I did, I think one single stream. I pushed myself that day, but that also made things worse. But now I'm here, and today we are going to start from what we left. Then we are going to watch a funny video basically. Let me make sure this is good. We are going to watch a funny video I saw regarding tech. I'll just put this on my list here. Networking module, then those two things that are on my plate, right? So with that being said, let me start sharing my screen, and then we can go ahead into our stuff. Alrighty. Okay, hopefully you guys can see my screen and everything. We were at layer 2 of OSI model, and let me refresh. Hopefully I'm not thrown out. Okay, it logged me in, that's good. Wait, we were actually at layer 3 because we were going from layer 7, 6, 5, 4, 3, 2, 1 to do because it's much easier to go with that, right? It's easy to understand. Level 7, we talked about the application layer, which is the GUI, the things you see, right? With the HTTP and what all applications like file transfer protocol and all those stuff. Then we have the presentation layer with the HTTPS, where it's like how the things look and also the encryption and some other things that happen at this level. This one is more about FTP and all those things that are kind of the at the end what you see, right, as a user. These are the type of things you see as a user. Presentation is more about standardization, like all the websites are talking in HTTP. Session is, let's say, if you are going on a website to maintain a session, so you don't have to keep on logging in every time you are clicking a button and all those, creates a session. Transport, how the data you are sending and receiving is transported, your IP address and all that information. Now we are going over TCP is that one, right? But your routing is here, more like your IP is like kind of in the middle, I will say 3 and 4. But yeah, so we are going to go over layer 3 network layer, because if you see at transport, right, we are sending the traffic, right? Here, which traffic, how things will go, different packets, how they go from one place to another, one server to another, and all those stuff. Like even your streaming, your WhatsApp video calls, those are UDP, others are transfer TCP, like the streaming. Here, this one is the networking one. Network layer, the third layer of the OSI model. The third layer of OSI model, also known as network layer, is where the magic of routing and reassembly of data packet takes place. From these all small chunks to the larger chunks. So the one image of we saw of the cat right here, you got like, let's say, three packets. You got how, like, basically the data, the packets are going to be sent from one web server to your computer, like from Facebook or YouTube to your computer. But if packets are received, like whichever order, right? For example, let me give you a beautiful example. Let's say you got a package, right, of furniture, and things are being sent in a way as they are being prepared. So this is the starting point. This is your house, and here this is, let's say, the shop. Oh, my handwriting is much better. So there are, let's say, multiple tracks. Let's say the first one was sent with this one, this path. This is the path 1. I jinxed it. Now it's good. Okay. Path 1, path 2, and path 3. For example, let's say for some reason they had to send it to different paths. When you received them, let's say you received the first one first, but third one was the second, and second part was the one you received last. Now, when you get furniture, you don't just like put things as you receive them. You put them based on where one should be, right? For example, let's say if you are having a house, right? You put basement first, then the house, then the roof. You don't go roof, then the bottom, basement, and then the house, right? Doesn't make sense. So that's those things, which packet should go where, happens at the layer 3 of OSI model. As it's mentioned here, magic of routing and reassembling of data takes place. So here also, this thing you see, right? These paths, this one here, this one, and this one. This routing, how you go, takes place as well here. From small chunks, small furnitures, to a bigger proper sofa or whatever. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. So first of all, let's say instead of sending these 3, they will look, okay, how what is the best way to send, so we can send all of them. While some protocols of this layer determine exactly what is the optimal path that data should take to reach a device, we should also only know about their existence at this stage of networking module. Briefly, these protocols include OSPF, Open Shortest Path First. Here's the important thing. Open Shortest Path First is a very beautiful protocol, and like the concept is very simple. And there is, I think it uses, if I'm not wrong, Dijkstra algorithm to find the shortest path, which if you are in computer science or tech, it's a very good algorithm to practice your coding skills on. Then we have routing information protocol. The factor that decide what route is taken is decided by the following. What path is the shortest, i.e. has the least amount of devices that the packet needs to travel across. What path is the most reliable, that is the packet have been lost on that path before. For example, let's say if you take, let's say if from point A to B, right, there are multiple roads. Road 1, 2, 3, 4, right? We have 1, 2, 3, 4. Now it is possible that 1 is just 1 kilometer long, 2 is 2 kilometers long, 3 is 3 kilometer long, and 4 is 4 kilometer long, right? Let's take that for example. 1 is the shortest, so you will take that. But let's say if there is like problems at that road, like there are people who are just down making their TikToks on the road, not the best road, right? You want to avoid those things because it's a virus. But also like because there could be like some construction going on, things might be happening, right? It's broken, or traffic is a lot because everybody else is taking it. So those could be the reasons. That's when it comes to reliable. Shortest one was 1, but reliable, let's say, is the number 3 or 4. What path has the fastest physical connection? That is one path using a copper connection versus the fiber one. What this means here, right? Path 4 might be the longest, but let's say if it is a straight line, much faster than let's say path 2 or 3, which are like this, right? Because there are so many turns, you can only go at a smaller speed. This one, go 100. So those are really like 3 main factors that they decide. And interestingly, some protocols prefer one over the other. That's why there are multiple protocols at this. At this layer, everything is dealt via IP addresses such as 192.168.1.100. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices. because they are capable of working at the layer 3 of the OSI level. What that means is basically because of the IP addresses where computer addresses, right? How to deliver those packets using IP addresses, right? These devices do that job for you. So that's what they are called level 3. If there is, let's say, level 4 router, that's called level 4 device, right? And that's where, here's the thing, router is the level 3 plus level 4. These layers are very, very like interchanging, almost like have a Venn diagram, right? They are almost overlapping. What is the name of this layer, right? Name will be network. Will packets take the most optimal route across a network? Yes. What does here's the thing, optimal has different names, remember that. What is the best path? Some will say the secure part is the best part. Some will say fastest one is the best one. Depends. What does the acronym OSPF stands for? This one is open system. No. Open source open shortest path first. Okay, sorry, I never remember these things. Path first. What does the acronym RIP, routing information protocol? This one was easier to remember. What type of addresses are dealt at this layer? This layer, you do IP addresses. Sweet. So now this is level 2. We are the last one. We'll talk about level 1 again because we did talk about bottom ups. The data link layer, this is your Ethernet layer or the MAC address, right? The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, basically your router, including the IP address from the remote computer, and adds it to the physical MAC addresses or MAC address of receiving endpoint. Inside every network enabled computer is a network interface card, NIC. This is very important because network interface card is, let's say if your computer has 2 network interface card, it can have 2 different IP addresses, which comes with a unique MAC address to identify it. Here's the thing, why you will have multiple MAC addresses, network interface cards. You probably can have a server where you want to isolate even to a hardware level or layer 2. So you want to have multiple, a server with the motherboard, so it can have multiple network interface cards. So multiple users will have a static MAC address. They can talk about it, they can play with it, but not with somebody else's MAC address. That's how you can play with the servers, right? MAC addresses are set by the manufacturer and literally burnt into the card. They can't be changed, although they can be spoofed. So for example, let's say if I'm sending information, right? Let's say this is Facebook. I'll do blue for Facebook. This is Facebook, right? I'm talking to Facebook. This is my home or me, right? So now MAC addresses are a thing, right? They are talking. So I will know Facebook's MAC address. They will know mine. What can happen is somebody might have got this connection and is listening, right? They are listening whatever is data going from here, and that so forth. Now this attacker, why it is important to learn this as a cybersecurity professional. So if you are the attacker, right? If you spoof, you can create a request sent to, let's say, me, where you can ask again, let's say what is the password or whatever. Let's say password and username again. Why? Because this might be encrypted, But what you know is the MAC addresses of these things. The data inside them might be encrypted, but if you know the MAC address, an attacker can spoof the MAC address, can spoof so that it looks like, oh, Facebook just might have, the connection might have ended, session might have ended, so send me a MAC address. That's when you can get one. That's the attacker. That's man in the middle attack. One example. Another one could be, let's say, if you want to DDoS in network, a lot of them look for IP address, but also, let's say if somebody's smart, right, they put MAC address also and block all those. You can use MAC address, right? MAC address also as one of the things you can spoof, so nobody is traced back which person bought a particular MAC address or this device. Bunch of good reasons. When information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information, right? Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission, right? So it has to be standardized again. And also, if you are sending it through, let's say, network and all those layers at level 3, 4, 5, 6, 7, you have to make sure it's in a way, it's like, it's not, if you send it a box, let's say if you are sending a, let's say you are sending a packet, right? If you send it like in a information, you send it in an envelope, like a small one, easy to send. But what if you are like putting it in a 100 kg box, your information? That cannot be transported everywhere. That cannot be done in a proper way. So you want to make sure the data is done in a proper. You need encryption, so you can have like another mail up here, right? Encapsulated it, but need to understand, you have to be smart. It should work, right? And security is the last thing, because that's how the world works. So this one, name of the layer, data link. What is the name of the piece of hardware that all network devices come with, right? This is what you need to know. And that's why I will say interface, everybody in one network interface card, sorry. And that's why I always say, like, everybody should build their computer at least once, so they know exactly what's going on, right? And let's cover quickly with the physical layer. Physical layer is your Ethernet cable, your coaxial cable. This is what, if you were in the same time zone as me, right, you will see TV with coaxial. I belong to a time where we had connections like these. This is where the coaxial cable go for your internet cable, right? You see there's a screw and everything. This is how things work related to antenna. This is an image, a real image of how things work. And I can show you coaxial. Nowadays it's all optics outside the house, and inside it is mostly Ethernet. It's important to just like have a touch of these things, understand how these things work, right? Because I'll give you an example of why I know very well how this works. Because when the exams used to come, my father, because I was used to watch TV a lot, right? My father will like cut this part of it, right? Make it a bit smaller. So this cable, because this thing, the copper wire was needed to send the signal from the antenna to the TV, my father will cut this. And if it is cut, right, I can't watch it. But then once it is working, once it is good, what we used to do is like we used to burn the plastic out here. Outside installation, copper mesh and all those, these can burn. So you used to take it out or like just burn it to get it done. And that's how basically things work with coaxial cable. Just an interesting thing from my childhood. My interesting childhood. I love my dad. Now here we're talking about practical OSI game. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff high score of 19 seconds? Click to view button on the right to start. Escape the dungeon to retrieve the flag. So let's see if we can do in 19 seconds, right? Let me play a quick thing here. Okay, so you guys can see seconds are here too. Let's bring up this website. TryHackMe. Let's start as soon as it reaches 7:23. So I can see our hacker has been logged in the dungeon. Their only chance of freedom is by choosing the correct path based on the OSI model. Use your cursor keys to move left and right, and spacebar to enter the doors. Bro, just reading took more than that. So insert coin. Let's see. Two. Play. What is the question? Hacker. First one will be physical layer. Now will be data link layer. Network layer. This is a nice one. Transport layer. Session layer. Presentation layer, application layer. Okay, I think I'm also on the same 29 seconds. Holy, I thought I said 19. Well, hopefully you guys got the idea right in the game. This is the flag we have. A very interesting game. Basically, they're asking if you can remember from bottom up. If we go again, right, just to give you guys an idea, a very simple idea, we have our hacker, right? We have to go from bottom up in the OSI model. So first our hacker is here, right? Oh, you guys probably can't see because of the captions. I'll turn that off for a second. Here, so you guys can see the hacker, right? On the left, we can move left and right. First one will be physical. Physical layer is the one with your coaxial cable, optic fiber, which is going on a lot nowadays. Second is data link layer. This is your network interface card, which is in your, let's say, hard on your motherboard, and you can have insert mode depending on the type of motherboard you have and stuff, right? And you can have multiple of those too. And you can spoof it, you can't change it, unlike your IP address. Next is the third layer is the network layer. This is your router, where all the frames you received will go and like properly put together like an image. Next is the transport layer, because there are packets how it will go from, let's say, Canada to India, those type of things. Next will be the session layer. Session layer is, let's say, once the things are transported, you are on Amazon, your session should not expire. Like every click you make, you should not be entering your password, right? There is a session for a particular amount of time. That's that layer. Now it will be the presentation layer. Why presentation layer? What's the point of presentation layer? Is because there should be a standard way of how emails should look, right? Outlook can have its own way of looking. Gmail can have its own way, but a standard on how email, the service works. And if you see, right? And last is the application. This is what you see as a FTP, because you have the website HTTP coming from presentation. That's the standard. But how those things looks inside Facebook, how it looks, Outlook and Gmail, the difference is how it looks comes from the application side. And there we go. Nice. So hopefully that makes sense. Now let's go towards packets and frames. This is an important one, because if you're going to Wireshark, you want to listen or have like, you know, a spy like idea of able to listen things and stuff. This is the place, packets and frames. This is your building block of Wireshark also, I'll say that. This is done, taking its time forever. But we did all the other ones, right? Okay, cool. Now let's look at packets and frames. Understand how data is divided into smaller pieces and transmitted across a network to another device. Remember, smaller pieces, right? And transmit it across a network. So this is why I was giving you the furniture example. When you get, let's say, a big furniture like a sofa, a L-shaped sofa, and one, let's say, love seat here. This is how things work, right? With your sofa and everything. You don't get like a whole L-shaped sofa in one chunk. How it will be? A real one. Actually, I know this, right? It will come 1, 2, 3, 4. Let's say it comes in like these pieces. So they are dividing into 4 pieces so everything can go in a truck and get it. That's exactly how these frames and packets work. How data is divided into smaller pieces. The sofa is divided into smaller pieces, transmitted across a network, let's say road, to another house or a shop, from shop to shop, right? That's how the game is. So let's look at what are packets and frames. And it's important to understand their differences, how near they are. So you can use Wireshark to, let's say, listen to someone's conversation. Packets and frames are small pieces of data that, when forming together, make a larger piece of information or message. And let me give you a very beautiful here image of that. Oh, didn't work. All good. But if you see here in the transport layer, we saw there are packets coming, right? Packet 1, 2, 3, 4. And all of them together become a final packet. That's how the packets and frames they are saying is that packets and frame are small pieces of data. These ones, packet 1, 2, 3, when forming together, make a larger piece of information or message, the image of the cat. That's how things work. And in our case of sofa, all becomes a proper sofa, so people can, a couch, so people can sit on. However, there are two different things in the OSI model. A frame is at layer 2, the data link layer, the MAC address layer, meaning there is no such information as IP addresses. Think of this as putting an envelope within an envelope and sending it away, just like I mentioned in the message, right? Here, and that's called encapsulation. It's important to understand, because here, and you might have seen, right, if you, let's say, watch a spy movie, there will be one letter, let's say the main information or the secret. I think, let's say, put a secret to understand this. Let's say if I have a secret here in this safe, I want to put an additional layer of security for whatever reason, right? And that's how this works. So a frame is at layer 2. The green thing is your frame, layer 2, meaning there is no much information about the IP address. It doesn't know where things will go, who will be opening it. It just contains the secret. Think of this as an envelope within an envelope. The first envelope will be the packet that you mail. But once it is opened, the envelope within still exists and contains data. This is a frame. This process is called encapsulation. Basically, one cover over the other, right? This process where we covered the secret, the layer 2, the frame, with another layer, that's called encapsulation. Like a capsule, basically capsule, making it like a capsule, which discussed in room 3. At this stage, it's safe to assume that we are talking about anything IP addresses. We are talking about packets. When encapsulating information is stripped away, we are talking about the frame itself. So here, that's what they said. I think, give me one sec. So green part here is the frame. I'm just making it green so it's easier to understand. Frame, layer 2. And the white part, that's a packet. And this is your layer 3. This is where your IP address is. When you see, right, let's say you have seen those reels of Oh, I can tell in those Omega or online chatting places, right? Oh, I can tell you where you're located. They're looking at your IP address. I can tell which Google server I'm connected, because let's say Amazon, Google have thousands of servers. Which one I'm connected to, I can tell whether it's in Vancouver, Toronto, San Francisco, which one, because of its IP address. When encapsulating information is stripped away, we are talking about the frame itself. So this information is stripped away, the packet is stripped away, we are talking about number 2. Packets are an efficient way of communicating data across network devices such as those explained in task 1. Because this data is exchanged in small pieces, there is less chance of bottlenecking occurring across a network that large messages being sent at once. What exactly is saying, right, is so that things are easy to send. The secret, let's say, is divided into smaller chunks. S, E, C, oh, not the best spacing. S, E, C, R, E, T. All of them are in their own boxes. Layer 2. Oh. Here, right? This is how things work. So it's in S. Now encapsulation happen and layer 3 is added to all of those individually. And that's how the cat image is, right? Like all this information is put in and then one by one they are sent to the destination and so forth. Because the data is exchanged in small pieces, there is less chance of bottlenecking. So if you are not sending a very big package, it will go easily, right? It won't clog the pipes. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather small pieces where it is reconstructed on your computer. Packet 1, packet 2, packet 3, then sent is the final image from server to your like on Facebook, right? You are doing that. Take the image below as an illustration of this process. The cat switch is divided into 3 pieces. When it's reconstructed, it reaches the where it is reconstructed when it reaches the computer to form the final image. Broken into multiple pieces at the web server, sent over the network, and then finally, when all the packets 1 to 3 are received at the computer, it makes an image at our computer. Packets have different structures that are dependent upon the types of packet that is being sent. As we come on to discuss, networking is full of standards and protocols that act as a set of rules for how the packet is handled on a device. And important to know, I'll cover and I'll show you something important. With billions of devices connected on the network or internet, things can easily break down if there is no standardization, because we have IoT coming, we have Amazon Dot, right? So, and now AI, so many things, new protocols like MCP, so many things are coming. We need a standard. So we all know how all the devices around the world knows how to talk. Like for example, English, they know majority of the companies, people know how to communicate English. So it's kind of a standard. Or money, easy way to speak. Gold is one of the best example because that's how all people can do exchange, right? And one thing I want to show you, I think if you are interested in this, right? If you are interested in this, Cisco, there is Cisco Packet Tracer. Play around with this to understand networking. And Cisco's RNS certification, Cisco's CCNA certification, also called routing certification. Which one is that? CCNA, right? This one is particularly about these things, about these standards and stuff, and it's also like one of the starting ones, right? You take to understand networking and get into a network administrator, right? Broad range of fundamentals, right? A beautiful certificate. Some of my friends have done it who work in the government, so they all mention this. Let's continue with our example of the internet protocol. And why Cisco? Because majority of the company uses Cisco devices, so it's better to take codes from them, right? is they will train you on that in compared to a Network Plus, which is also good. Network Plus is more vendor independent, but Cisco will give you a bit more deep dive, and it's a bit harder than Network Plus. Let's continue with our example of the internet protocol. Your IP address, internet protocol address. A packet using this protocol will have a set of headers that contain additional pieces of information to the data that is being sent across a network. Let me show you exactly what that is. So if I refresh, right, on my computer, on this Chrome, you see a multiple, these are API calls that are being made in the network, in the network tab, right? Let's say if I pick any easy one, let's say notifications. You see the headers, there is so much information. These type of headers they are talking about. I should technically not show this because it could have some extra information, right? But basically these headers, that's all. That is being sent over the network. Wrong one. Did I close mine? Oh yeah, I closed it. My bad. Okay. So that's what it means, right? Set of headers that contain additional pieces of information to the data that is being sent across a network. And there is something called header injection. Not everything is vulnerable with very few things are header injection vulnerable, but still a good way for bug bounty. Most notable headers include time to live. This is about packets. TTL. This field sets the expiry timer for the packet to not clog your network if it never reaches the host or escape. So let's say if you are sending thousands of packets every minute, right? It doesn't clog. After let's say 10 milliseconds, the packet will die. And you can try it with the ping command. Checksum is a very important one. This one you might have seen every time you download, right, from a good website, like for example Kali download. If I'm downloading Kali's images, right, I'll go with the virtual image. You see there is a thing called sum here. This is your checksum. The field provides integrity check of protocols such as TCP and IP. If any data is changed, this value will be different from the one expected, therefore corrupt. What it means, let's say, with the Kali example, right? I have Kali. I want to download Kali, right? Now, two scenarios can happen. First, the green one, in which, let's say if I'm downloading, I receive it properly, everything is good, right? I receive it, it's good. And if I create a checksum of this, right? If I create checksum of this, it's a very easy command, right? If I create a checksum of this, it should match with Kali's checksum value, this one, right? Because again, Kali image, it's let's say 1 GB, it got divided into hundreds of pieces, right? Became together, right, as a whole 1 GB again. And 1 GB's checksum should be equal to the 1. Now, a red one where, let's say, a hacker attacked the network I'm talking to, attacked Kali's website, whoever it attacked, right? It went right through it. Let's say it changed out of 1,000 packets, it changed, let's say, one of them. And I received, let's say, again 1 GB of data because very hardly a change was made. Now, this 1 GB's checksum will not be equal to this one. And that's how I can tell there was a man in the middle attack happened. And every single download, so many places you are downloading something directly, they know this issue, right? And that's why a lot of them provide checksum. And you can find, there are checksums you can get, right? There is a very simple, there are more than enough ways which SHA sum, right? 256, you can talk about algorithm. Here, if you saw, This is the command, and you saw 256. So that's the algorithm you want to see. It's like kind of a zip version, or like a fingerprint. A fingerprint is a better word of this. A fingerprint of thing you are downloading. Hopefully that makes sense. Hopefully you're learning something, right? If you do and you're liking this information, let me know. I will provide more when things come. Or if you want me to stick to the course, I'll do that too. Next is the source address, right? Things that are in the header. Source address. The IP address of the device that the packet is being sent from, so that the data knows where to return to, right? And the destination address. And this you have 100% seen all the time, because if you are creating an envelope, right? I don't know if you have ever sent it. There is always a from, to, right? Those things are there. And that's the same idea in these packets. There is a from IP address and there is a to IP address. What is the name for a piece of data when it does have IP addressing information? Basically, it's asking whether it is a packet or a frame. And then next is what is the name of the piece of data when it does not have IP address? Basically, when we were talking about the secret thing, right? What is called, the second one is this green one. The first one is this white one. What is it called? We already talked about this, so I'll just go ahead. Packet. Next is frame. Beautiful. Now let's look at TCP/IP, the three-way handshake. Three-way handshake. If you are in what's it called, tech world, or if you are in computer science world for even a little bit, a year, you might have heard of this. The three-way handshake. Very important concept. And this is like, if you are going as a student or anything, you need to know this. You need to know this. TCP, or Transition Control Protocol for short, is another one of these is another one of these rules used in networking, a protocol. This protocol is very similar to the OSI model that we have previously discussed in room 3 of this module so far. The TCP/IP protocol consists of 4 layers and is arguably just a standardized version of the OSI model. These layers are application, transport, internet, network, interface. One sec, let me drink some water. So, the TCP/IP protocol consists of 4 layers and is arguably just a summarization version of the OSI model. What it means is layer 7, and there is a TCP/IP what's it called model as well. If you see OSI model versus TCP/IP model, just see a comparison. This is a better one. No, let me find one. Yeah. So if you see this image, right, application layer in this one, right, is basically this, but presentation, session, and transport are basically eaten by the transport here. Presentation and session mostly, right, are eaten by the transport layer, layer 4, and including the network one, the last one. Why it is like this is just how you want to define things, right? How you logically want to put things together. Some people agree with the OSI one because it's well divided, right? And some people agree with the TCP model. Both technically works. Very similar on how the OSI model works. Information is added to each layer of the TCP model as the piece of data or packet traverses it. As you may recall, this process is called encapsulation, basically putting information again one by one, where the reverse of the process is called decapsulation, where, remember, we had secret and packet, right? The frame and packet. Now, if I want to remove, this secret is sent, right, to the, let's say me, I'm James Bond. The secret is sent to me. And I have 2 layers. One is the green one, second is the white one. I want to remove the white one, let's say with this eraser, to get to the secret, right? And that process is called decapsulation, because first I'm encapsulating, putting layers, I'm removing the layers, it's called decapsulation. One defining feature of TCP is that it is connection based, which means that TCP must establish a connection between a client and a device acting as a server, basically let's say Facebook and my server, before data is sent, right? A connection has to be there. Because of this, TCP guarantees that any data sent will be received on the other end. This process is called three-way handshake, which is something we'll come on to discuss shortly. A table comparing the advantages and disadvantages of TCP is located below. Guarantees the integrity of data. It guarantees you will get the data and it will be right. Capable of synchronizing two devices to prevent each other from being flooded with data. So basically it's checking that, let's say a server, right? Facebook server is like very massive, way more massive than mine. So if it is, let's say, sending a video, or like even with YouTube, right? Those so that you are not getting bombarded and your network doesn't go down, it will keep a check of how many I should send. Okay, I should send 10 packets every second, or what should be it, and it keeps checking so that it knows, okay, is it getting clogged? I will send less. If it is not getting clogged, there is like a lot more space, I will send more, right? Performs a lot more processes for reliability. Bunch of processes it does, like checksum and all those. Now, disadvantage: require a reliable connection between two devices. If one small chunk of data is not received, then entire chunk of data cannot be used and must be resent. What it means is, let's say, in this, how TCP work is, let's say, if I have this couch, right? This is my sofa, whatever. I don't know the difference between sofa and couch, is if there is a difference, but let's say this is a sofa, a L shape and love seat, right? Let's say if I didn't receive like the second one, I didn't receive this, will I be able to use it? No, right? So that's the whole idea of TCP. Hey, if you are not able to get one for any reason, the whole idea, they will send a whole piece together again. That's what it says. Requires a reliable connection between two devices. If one small chunk of data is not received, the entire chunk of data cannot be sent and must be resent. A whole new sofa will be resent. The previous one will be just basically removed or taken out. A slow connection can bottleneck another device, as the connection will be reserved on the other device the whole time. Basically, one person can have connection depending on how good your connection is or network throughput is. TCP is significantly slower than UDP because more work with checksums and all those checking is required, has to be done by the devices using this protocol. Why? Best example, TCP memes are the best way to learn. One image. You see this, right? Data, this one, the TCP one here. This one takes time to send the baby from, let's say, its parents to another guardian, right? Another relative. Now look at this one, the best way. You are sending the kid, just throwing it. If the kid is hurt, whatever, but this is the faster way to send the kid to its relative. If it is my relative's kid, 100% do it. Just joking. TCP packets, hopefully that makes sense though. TCP packets contain various sections of information known as headers that are added from encapsulation. Let's explain some of the crucial headers in the table below. One actually thing is interesting. Somebody did ask me when I showed this image, why would anybody want to use TCP if the data is very if they don't want to throw data, or like because they are thinking of baby as an example. Now instead of baby, think about it as a ball, right? If you are playing, let's say, cricket, baseball, you throw the ball, you do not go hand over the ball, right? So depending on the use case, you throw, or you want to make sure that it's reliable, You want to do that. And some places both will work. For example, video, right? If you are doing a video call using WhatsApp, it uses UDP. But if you are doing a video streaming like mine, I'm using TCP with YouTube. So you need to know those things. TCP packet contains various sections of information known as headers. That are added from encapsulation. Let's explain some of the crucial headers in the table below. The source port, right? Which port, right? Which gate in your computer should know this? Because if you have, let's say, the address belongs to a apartment building, which unit in the apartment building? That's what it means. Destination port, same idea, right? If let's say the packet is not sent or they want to send me, what should be the destination? Majority of the time, it's either 80 or 443 for a website. 443 for a secure one. Source IP addresses, right? Destination IP address of the destination. Sequence number, that's a big one. When a connection occurs, the first piece of data transmitted is given a random number. We'll explain this more in depth further on. But this number, there is a number given, a random number, let's say 1000. Acknowledge number. After a piece of data has been given a sequence number, the number for the next piece of data will have a sequence number +1. That's the whole idea when we were talking about like the image of the cat, right? Packet number 1, let's say serial number was 1, next will be 2, next will be 3, so it knows. Okay, we'll also explain this more in depth further on. Checksum. This value is what gives TCP integrity. The one I talked about, right? Checksum of the Kali when you're downloading that software. And let me actually turn on the caption again. Apologies, I forgot. Checksum, right? Integrity. The value is what gives TCP integrity. And this is, now you know, will be missing in the UDP. A mathematical calculation is made when the output is remembered. When the receiving device performs the mathematical calculation, the data must be corrupt if the output is different from what was sent. One sec. So a mathematical calculation is made where the output is remembered. So whatever is the output, let's remember it, the packet, right? When receiving data performs the mathematical calculation, data must be corrupt if the output is different from what is sent. A man in the middle attack has happened. Somebody has looked at your data, changed it, whatever. Data. The header is where the data, this header is where the data, that's the bytes of the file, is being transmitted. Flag. This header determines how the packet should be handled by either device during the handshake process. Specific flags will determine specific behavior, which is what will come to explain below. What are flags? Basically, there are 3 types of flags or more, but main 3, which you will be asked questions about if you are going for exam. Next, we'll come on to discuss the 3-way handshake, the term given for the process used to establish a connection between 2 devices. The 3-way handshake communicates using a special messages. Using a few special messages, the table below highlights them. So first one is the sync. A sync message is the initial packet sent by a client using the handshake. This is the one, let's say you are saying somebody hello, you are saying namaste, you're saying bonjour, something like that. That's what sync is. This packet is used to initiate a connection. To tell somebody hello, right? You are initiating a connection and synchronize the 2 devices together. Sync and acknowledge. Somebody says, hey, how are you? Sync and acknowledge. This packet is sent by the receiving, so the person you said hello to acknowledge the synchronization attempt from the client. So, hey, other person is also interested in talking to me. Last one, the acknowledgement packet. I am good. How are you? Acknowledge. Okay, I acknowledge. I also want to have a conversation. The acknowledgement packet can be used by either the client or server to acknowledge that a series of packets or messages have been successfully received. Right? Now, data. Once a connection has been established, data such as bytes of the file is being sent via data message. Type of message, right? First three are like about handshake. These three are the handshake one. Last one is the data, where we are talking. We are doing data all the time. This packet is used, the fin one is used to cleanly close the connection after it has been completed. So let's say after spending an hour on Facebook, I'm done. I want to close it. So I will send this last message. This packet, the last one, RST, this package abruptly ends all connection. This is the last resort, indicates that there was some problem during the process. For example, if the service or application is not working correctly or the system has faults such as low resources. Now, here's the thing. This is the one, let's say low resources, so battery died. The connection could not be done closed properly because your computer's battery died, your electricity went off, or some virus took over, whatever. In real life, right, you are talking. So first you say hi, other person says hi, how are you? You say I'm good. How are you doing? And all those information, right? Blah, blah, blah. Now you want to say, okay, I have to go. Bye, see ya. Next one, you are just like, this guy is talking too much, I'm running. This guy is a psychopath, I'm running abruptly. Just those examples. Now let's see that in real world. The diagram below shows a normal three-way handshake between why it's called three-way? Because the first three messages are needed to make sure the connection is established, right? In real life, this would look like sync and acknowledge. Any sent data is given a random number sequence and is reconstructed using the number sequence and incremented by 1. Every time a message is sent, 1 is added to it. Here, sync, let's say, is 1. Sync and acknowledge, the second message will be 2. This acknowledge will be 3. Right? 1 is added only. So it could be, let's say, random number would be like, let's say, 1000. Next one, this one, if sync was 1000, this will be 1001, 1002. And data will be, let's say, 1003. And then data again, 1004, blah, blah, blah. And at the end, whatever fin and a reset will be. Both computers must agree on the same number sequence for data to be sent in the correct order. So both has to agree it should be on starting from 1000. This order is agreed upon during 3 steps. Sync client, here is the initial sequence number to synchronize with 0. Server says, okay, here's my initial number, synchronize with 5000. And I acknowledge your initial number, this. The client says, I acknowledge your initial sequence number. I agree with your one being 5000. Here is some data that is my sync 01. 01, right? Final number, it's increasing by 1. So it should be like, let's say if it was starting from 5000, it will be 5001, 5002, 5003. To synchronize with 5000. TCP closing a connection. Let's quickly explain the process behind TCP closing a connection. First, TCP will close a connection once a device has been determined that the other device has successfully received all of the data. Basically, what it means is when we were sending the cat image, right? Let me bring that up quickly. Let me open this again here. Here, the connection will be closed once the computer tells the server, hey, I've received all the data I wanted. Now close this connection. I just wanted the image of the cat. Now read it again. Let's quickly explain the process behind TCP connection, closing a connection. First, TCP will close a connection once the data has determined that once device has determined that the other device, the server, knows that your device, your computer has received all the data. Right now, because you're looking at my screen, I'm talking to you, there's constant, you are messaging, sending like, right? The communication is going on, right? So the connection has not closed. Let's say if you close the YouTube app, please don't right now, then the connection is closed. That's how it is. Same, a lot of time images, let's say if you want to download image, you downloaded the image, connection is closed from the server or anything you want to download, right? And that's how it works. Because TCP reserves system resources on a device, it's best practice to close TCP connection as soon as possible. As soon as you have received, let's say you were downloading a game, as soon as that's done, connection closed to the web server. Done. To initiate, and this is a very common thing, this is a very common protocol. It's like English. All the companies, all the people are using this. To initiate the closure of a TCP connection, the device will send a FIN packet to the other device. Of course, with TCP, the other device will also have to acknowledge this packet. So again, this handshake goes, right? A proper gentleman connection is going on, like we say. Let's show this process with Alice and Bob. Alice is the server, FIN. Bob is like, acknowledged your FIN, and this is my FIN. Alice will like, okay, acknowledged. In real world, it would be, hey, I have to go now. Have a good day. Right? Other will be like, okay, have a good day. I have to go too. Okay, done. Like that type of conversation. Or like, better example would be, first one, FIN, I have to go now. Bob will be acknowledged. Okay, I have to go as well. Right? Acknowledge. And FIN will be have a good one. Acknowledge. Last by Alice would be you too. Something like that. A gentleman conversation, right? In the illustration, we can see that Alice has sent Bob a FIN packet. Because Bob received this, he will, one thing I just noticed, actually very funny thing, I feel like for a long time on my internet streaming journey, I won't be getting those type of questions like, oh, you didn't, why you're saying gentleman and why not gentle person? I think all those type of people are just too busy on Twitter, like being Karen. So I'm very happy about that. I'm very happy. Cheers to you lads for not being like that. In the illustration, we can see that Alice sent Bob a FIN packet. Because Bob received this, he will let Alice know that he has received it, acknowledge, and then he will also wants to close the connection using FIN. Alice has heard Bob loud and clear and will let Bob know that she acknowledges the closing again, his FIN as well. What is the header in a TCP packet that ensures the integrity of data? What is this called? Please answer this. I would love to hear an answer because I showed you that so well. Please. Just a message will make my day. Please do that. Forget about subscribe, like and everything. Just send me this message. I want to see you are learning something here. Next, provide the order of the normal TCP normal three-way handshake with each step separated by a comma. Okay, so 3 steps of the initial TCP when you're establishing a connection, right? So if this one, right, this is called integrity, is done when I was saying about Kali here, right? I was talking about Kali, how they are done using checksum to know an attacker hasn't hacked your or like did a man in the middle, right? Checksum. Next, this one is easy. First is sync. Hey, I want to synchronize with you. The other person says acknowledged. We can, and other will also say sync. Wait. Sync. Oh, ACK. Yeah. So sync, acknowledge. Now, let's do a practical handshake and how things work. Help Bob Alice communicate by reassembling the TCP handshake in the correct order in the static lab attached to this task. Enter the value of the flag given at the end of the conversation between the questions below. So here, we have Alice and Bob. Can you hear me, Bob? Goodbye and what? Right? So first one is synchronization. Hey Bob, can you hear me? Yes, I can hear you. Okay, great. A very beautiful, easy communication, right? Now we are talking about cheesecake is on sale, right? All the data. And it will say, maybe it can say repeat or reset. Acknowledge, I hear ya. because it received the data, let's say. So because the connection is established properly. And then it will be like, either it can say okay, right? Depending, okay, yeah, I hear, yeah, okay, you can hear me, good. Or it could be fine and acknowledge. Should we do retry? Let's see if this works. No. It says, okay, that's all I wanted to tell you. The cheesecake is done. Okay, received. But I'm saying, yeah, me too. And then it will fin acknowledge. This will just do acknowledge. Right? TCP chatter. I can't copy paste this. That's sad. Okay. Hopefully that makes sense. Okay, let's finish this today. Now we have UDP IP port. UDP and IP protocol. UDP, user datagram protocol. This is a very interesting protocol in my opinion, because the applications of UDP protocol, right? You might not even know you're using them, but if UDP wasn't there, those applications with TCP would be hell of a thing to build and very hard to do. So that's why it's important to learn this one as well. And sometimes you want to use UDP, let's say for security reason. Let's say you just want to send the data which is super encrypted, and if it doesn't reach you, right, doesn't reach the destination in a certain time, delete it. Done. And you don't want to send a connection. It would be like a C2 server. I don't know if you know about C2, command and control hack, right? You are just sending information one way without knowing if the other person is receiving it or not. So the user datagram protocol is another protocol that is used to communicate data between devices. Unlike its brother TCP, UDP is a stateless protocol that doesn't require a constant connection. What it means as stateless is that in TCP we were making sure, right? Let's say it was Alice. And Bob. We know if Alice sent a fin1 for the whole state of the game or the whole, let's say, connection, fin and another fin is sent, we know we don't have to send fin again, right? A state is there. We know. Just like a vending machine. When you type, you have put in the money. It won't ask you to put money again. It will ask you to type. There is a state save. It knows what you did before. That's called a state. It knows what you have done before. UDP doesn't care. UDP does not care. It has what's it called, I think, Alzheimer or something. That's how UDP is. It's a stateless. Doesn't care about the state. Doesn't care what you did before. Tell me what right now. UDP is a stateless protocol that doesn't require a constant connection between the two devices for data to be sent. So if let's say I have created a virus, I'm just sending data. Whether it receives this or not, I don't know. But it won't tell me till, let's say, the virus I have hacked the world. Whatever. For example, the three-way handshake does not occur, nor is any synchronization between the two devices. It won't know. Recall some of the comparisons made between these two protocols in room 3 of OSI model. Namely, UDP is used in situations where applications can tolerate data being lost. For example, like a video streaming or video chat or voice chat, right? Like if I'm calling, right? It's not that important. Or Zoom, it's okay for those things to lose. Where an unstable connection is not the end of all. A table comparing the advantages and disadvantages of UDP is located below. UDP, because it just starts sending the data faster, leaves the application to decide if there is any control over how quickly the packets are sent, right? Basically, I am deciding how much I want, right? It won't check like how much network is capable or not. It depends on me and my software, how much I want to give. UDP does not reserve a continuous connection like a device, so it does not has to keep a connection going. Disadvantages: UDP doesn't care if the data is being received or lost. If you want to send like an email, then UDP is not the best way. It is quite flexible to software developers in this sense, right? Because it doesn't have to make sure the connection is there, session is, all those things are there, right? Important checksums and stuff. This means that unstable connection results in terrible experience for the user. That's why, like not exactly this is the reason, but other companies, that's why a lot of time when it comes to video calls, they're asking how was your experience. Might be related to this, right? They want to see how's their protocol building, UDP use, or if they can improve the protocol a bit. And TCP and UDP, if you want to learn, TCP is a whale, and people do PhD in it. Just saying. As mentioned, no process takes place in setting up a connection between two devices, meaning that there is no regard for whether or not the data is received, and there are no safeguards such as those offered by TCP, such as data integrity. So checksum is not a thing. UDP packets are much simpler than TCP and have fewer headers because it's not checking the checksum, no sequence is there, nothing is there, right? It's just sending data. However, both protocols share some standard headers, which is what annotated below. Time to live, right? Delete after certain time. Source address and ports are needed, right? You need to know where you are sending, right? It's not a radio show where everybody should be receiving it. Actually, radios is frequency, but they're giving you idea. Data, again, you need to send data, right? So very simple, basically. Strip down anything that's not important for UDP. From TCP, you will get UDP. Next, we'll come on to discuss how the process of a connection via UDP differs from that of a TCP. We should recall that UDP is stateless, no acknowledgement is needed, right? So diagram shows below here. Bob says, hey, can I get the image of the cat? Response, right? It gets the 3 images. So here, we have the questions. We are done with this task as well. So what UDP stand for, right? I would love to know. I know datagram protocol was the U. User datagram protocol. It's not that important, so I will say. What type of connection is UDP? Whether it's a state or stateless, we know stateless, right? Because unlike a vending machine, it doesn't care. What protocol do you use to transfer a file? To transfer a file, you need to make sure the file is received properly. You want to send using TCP. What protocol do you use for a video call? Not all video calls want to use UDP, but majority of them will do. Let's see if any video call service use TCP. Video conferencing can be either TCP or UDP, right? Depending on the quality and reliability, how much we want, right? Zoom uses UDP for real-time communication, but it can fall back to TCP when necessary for a reliable data transfer. Skype also uses this. WebEx also probably. Oh, WebEx uses TLS, all these three. Netflix is a whole different game. It's not a video call. It's more of a video streaming. So makes sense. That's using TCP. It wants to make sure you get all the parts of the movie, right? If some part is gone, would you ever watch that service? No. Port 101 practical. Let me just grab some water first. Perhaps aptly titled by their name, ports are an essential point in which data is being exchanged. Ports, easiest ways to explain, you guys, right? You have a house, right? There is a door, but let's say if I want to let air in, door is not the only way. There are windows, right? There can be so many windows. That's the whole game with your computer. There are so many ports. Some of the ones you see, for example, your USB port and stuff, but inside, network-wise, there are from 0 to 65535. So total 65,536 ports are there. Because it starts from 0, it goes to 65,535. And that's like one of them are used for connection. 80 is used for your websites, right? And 443 also for your website. Those are less than 1,000 are important ones, need to know, and other ones you can use for a bunch of reasons. For example, Postgres use 5432. I know them very well. I don't remember people's name, but I remember these. Ports are essential part in which data is being exchanged. Think of a harbor and port. Ships wishing to dock at the harbor will have to go to a port compatible with the dimensions and the facilities located on the ship. When ship lines up, it will connect to a port at the harbor. Take, for instance, there is a cruise liner cannot dock at the port made for fishing vessels or vice versa. These ports enforce that we can park and where if it isn't compatible. It cannot park there. Networking devices also use ports to enforce strict rules when communicating with another device. When a connection has been established, recalling from the OSI model's room, any data sent or received to our devices will be sent through these ports. So let's say if I set a connection with a Facebook web server over port 443, all my data will be sent through this. Let's say if I sent it through 8080, right, all my data will be sent through this. This doesn't change. In computing, ports are numerical between 0 to 65,535, right? So total, because it includes 0, total is 65,536. Y is 2 power 32, I think. 2 power 32 minus 1 or 30. How much is 2 power 32? No. Oh, 2 power 16. Yeah. 2 power 16 is this. That's why. Sorry, I missed 32 with 16. Okay. So, anybody know the reason why 16? Check this out. Find the reason for this before next stream. You will love it. Because ports can range from anywhere between these numbers, they quickly runs the risk of losing track of what application is using what port. A busy harbor is chaos. Thankfully, we associate application and software and behaviors with a standard set of rules. It's like, when you're going to catch a plane, right? Keeps on changing which plane will go to which gate and stuff. You're running. Unlike that, computer is much better. For example, by enforcing any web server, is all the web stuff, right? You are sending over ports has to be over port 80 or 443. Software developers can design a web browser such as Chrome or Firefox to interpret the data the same way as another, right? Because all are on port 30 or 443. This happens that all the web browsers now share one common rule. Data is sent over port 80. How browsers look, feel, and easy to use is up to the designer, but the main underlying technical stuff is over port 80. While the standard rule for web data is port 80, a few other protocols has been allocated a standard rule, right? A standard number, a port that is between 0 and 1024, right? Which is 2 to the power 10 is known as a common port. Let's explore some of them. So file transfer protocol 21, help in sharing files, right? Secure shell SSH to get a connection to the computer, port 22, right? Hypertext, this is your your website 80, but this is the HTTP, not HTTPS. That one is 443. Server message block SMB, right? This is same as TCP. However, SMB allows to share devices like printers. So basically, your printer in your organization, school, office. That's what 445 is. RDP is a beautiful one, 3389. Even though it's above 1000, RDP is such an important one because this is how you can hack into other computers and get remote access. Once you get remote access like this, you have hacked the computer, you gained it. This protocol is a secure means of logging into a system using visual desktop interface. And it's a lot of time already there in Windows 1. Even on Mac, you can find this application. Beautiful application. I use it, let's say if I'm in like a different city, I use RDP to connect to this computer at home to be able to do anything I want. We have only briefly covered the more common protocols in cybersecurity. However, you can find the table for first 1024 common, like 1024 common protocols listed more here. Okay, so I know important ones I will tell you is there is so many here. FTP is one, right? Trojan, okay, they are talking about WebEx, Invisible, okay. FTP is there, SSH is there, Telnet is there. Where is the one DNS one? Domain 53, there is one at 69, FTP, right? Same as trivial file transfer. There is SFTP, which is above, we left. Oh, discard, okay. I read it Discord, interesting. There is SFTP also somewhere here. SMTP is here. Okay. It's 115. Yeah. So I'll give you guys this information. Cheers. Enjoy learning 1024 protocols. I will say the more important just are like, let's say only 10 you need to remember. Majority of the time, that's more than enough. The one like being DNS, SSH, FTP, SMTP, SMB, HTTP, HTTPS, Postgres is a good one. Just database related one are also important. What is worth noting here is that these protocols only follow the standards. You can admire applications that interact with these protocols on a different port other than what is the standard, running a web server on 8080 instead of 80, right? Note, however, applications will presume that the standard is being followed, so you will have to provide a colon along with the port number. What it means here, right? I know TryHackMe server, because it is HTTPS, it's on 443, but let's say if I knew it was on port 8080, this will be my URL. A colon is added at the end. Useful when you are a developer because you want to set it up as 8080. And that's why it's important to understand these things. Open the site attached to this task and connect to the IP address with the port 1234. And why ports are important, you need to know, okay, like 4444 is not used anywhere. So to get a reverse shell, that's what you use. What is that flag received? Let's see. Okay. View site. We have netcat, right? And the IP address they want is 88.88. This is the Google's one, right? And 1234. Connection received. TCP, you are connected to a port. Very simple one, didn't even require much. Okay, continue your learning, extend your network. So extending your network, let's do that tomorrow. Join the final room for this networking module to continue learning. Terminate the static site lab deployed in tasks 3 and 5. So I'll just do that. And extending your network. Let's see what we will be covering tomorrow. The last one never works for some reason. But yeah, extending your network. Learn about some of the technologies used to extend your extend networks out onto the internet and motivations for it. So port forwarding, big. If you are looking into starting your business, this is my personal thing, right? I help so many local businesses with these networking things because they don't know about port forwarding. Their printer, like the billing one, right? When they, let's say, receive an order from Skip or their online website, those things are connected to a particular port. They don't know how to change the port IP addresses in their routers or the Wi-Fi routers or whatever, right? So that's what port forwarding is good for. Even it's great, let's say if you are set up a Raspberry Pi or some like another computer, you want to send a magic port IP to, or sorry, magic packet to. It's legit called magic packet. Then there are firewalls. I think everybody knows about firewalls. Practical. Then VPN basics is beautiful. Because you need to understand what VPN does, right? And that's kind of a basics of how Tor works. LAN networking devices. Because if you understand VPN, you will understand a bit about how dark web and Tor works. I won't tell you how it works. I can't tell you for reasons beyond my measure. Yeah, like I can tell you a little bit, which I will do, but just want to say. Then there is LAN networking devices. What is a router? How the switch works. These are important because now you can play with the things at your house and see if somebody has got inside your system or not, right? So we'll cover these things. That's a big one. Okay, finally. I want to see if I can reach this week as like a top player on TryHackMe. Okay, and after this we have going back to our PreSecurity because we are covering for PT1, right? Our certificate PreSecurity. Where is it? Come on, give me PreSecurity path. Nope, not here. So here I have PreSecurity we are working towards. Done 35%, good for us, right? We are done here, just the extending your network is left. Then we have how the web works. Probably, you know what, I will have time to cover not only the network, we'll complete the extending your network, but we'll also cover DNS and detail. We should have time, and along with HTTP. Yeah, we should have time to cover DNS because tomorrow I will have more time. Right now I have to go for a meeting. But then we will be able to cover HTTP as well. Yeah. HTTP is a big one too, and I will be able to explain a lot more because I am a web developer, right? So, and DNS sounds good. I will be able to get you these things work. And big one, those will be Linux and stuff. We'll just spend so much time. It'll be fun. But yeah, guys, hopefully you learned something, right? That's my goal with these things. Hopefully you are learning something. Hopefully you are inspired. Don't forget to join the Discord if you want to. Like I do, we do chat all the time there. And if you have any questions, you can ask me there or even from the whole community. Very helpful people, very amazing people like Bandit, Ben, amazing guys. So join the Discord. Feel free. It's a free Discord. You don't pay. And just enjoy. Yeah, have a great day. Keep it up, keep working hard, right? And follow your dreams. Till then, thank you so much. That's your boy Censored Hacker. Love you. I hope you have a great day. Pay it forward and don't shy away from helping anyone, and don't shy away from asking anyone for help. Thank you and bye. Bye everyone.